All right, Mr. Dresser, let's talk about some dilations. So a dilation is a transformation that will change the size of a figure, but not the shape. So it's going to be the same shape, it's just going to get bigger or smaller. The pre-image and the image are always similar. So we're going to talk later about the actual definition of similar. Pre-image and image, those might be new vocabulary words for you. Pre-image, pre means before, right? So this is before the dilation. This is kind of what I like to call the original image, the OG image. And then the new one after the dilation, this is called the image, or what I simply call the new figure. And you'll notice that the original, the points all are just regular letters, or sometimes we'll just give the shape a name, so like triangle A or triangle RED. But the image or the new shape, we put the little apostrophes on it. Those are called primes. So we would call this R prime, E prime, D prime, or we could say it's figure A prime. But the primes always go on the new figure. All right, whenever we're dealing with dilations, because they're getting bigger or smaller, we have what's called a scale factor, which I give a fancy definition for right here, but it's probably easier to just know that it's the number that you multiply by to get the new side lengths with similar shapes. So if it's getting larger and you're multiplying by 2 to get the new sizes, your scale factor is 2. If it's getting smaller, then your scale factor is going to be something smaller. Like if you multiply by a half, it's going to be half the size, so it gets smaller. So as you probably know at this point, K represents scale factor. And if your K is less than 1, such as 1/2, right? Or if your K is less than 1, we know that it is going to get smaller. The new figure will be smaller than the original. If our scale factor is equal to 1, so if we multiply by 1, well, if you multiply by 1, nothing changes. So this will be the same size as the original, which also means that no dilation actually occurred. But then the last option is if your scale factor is greater than 1. If we multiply by a number bigger than 1, the shape will get larger, which is a dilation. So when it's actually getting smaller or larger, those are dilations. And specifically, when they get smaller and larger, we give them some specific vocabulary, which are reduction and enlargement, right? Which we know to reduce something means to make it smaller. So a reduction takes the original and makes it smaller, which also means that the scale factor is less than 1, right? So K will be less than 1. And then when it gets larger, right, if we go from something small and make it bigger, that's an enlargement, just like when you take your pictures into the store and you get them blown up, right? Those are called enlargements. And this happens every time the scale factor, as we mentioned, is greater than 1. So if K is less than 1, it gets smaller or reduces. But if K is greater than 1, it gets bigger or enlarges. So how do we find the scale factor? Well, the way I teach it is to just say no. No, meaning N-O, meaning N-O, meaning new divided by original. So if we can take the new side length and divide it by the original, we can find what the scale factor was. So here's an example. I've got my pre-image or my original. I've got my new shape, right, my image, and clearly we can see that this shape got smaller. So it's going to be a reduction. To find out the scale factor, I can take any two pairs of corresponding sides. So maybe I take side AB and side A prime, B prime. They correspond. I'm going to do, right, my no. I'm going to do my new divided by original. And so my new side length was 4. My original side length was 8. So my scale factor is 4/8. Or you probably notice we can reduce this. Hey, it's a reduction, reduce, to 1/2. Or if you plug it in the calculator, you would get 0.5. So the scale factor for this problem is 1/2 or 0.5. It doesn't matter which pair of corresponding parts you use. If I did the same thing using this side and this side, and I take my new length, which was 5, divided by my original, which was 10, I'll still get 1/2, right? Same scale factor, or 0.5. Same thing would happen here. 6 divided by 12 would be 1/2. So the scale factor, 1/2. It also makes sense that it's 1/2 because it did get smaller. So we know the scale factor should be less than 1. Now, if we go from something small to something larger, we know we're enlarging it, and we know the scale factor needs to be greater than 1. But if I do my no, right, I take my new side length, I'm going to take this one, 32, and divide it by the original side length that corresponds to it, which was 16. 32 divided by 16 is 2. So my scale factor is 2. Again, scale factor means that's what I multiplied the original by to get the new one. So 16 times 2 is 32. 17 times 2 is 34. And 20 times 2 is 40. So sometimes if you get an easier one like this, you don't need to actually write anything out, right? I can look at this and go, oh yeah, 20 times 2 is 40. The scale factor is 2. But you can always set up your new length divided by your original. So new over original. Okay, so now I'm going to find the scale factor and then use it to find a missing side. So for this, I'm just going to pick two sides that I know go together. Right? I know that 9 and 3 will go together. I know that 9 is my new length. I know that 3 was my original, so new over original, and I get 3. So my scale factor, or K, is 3. Therefore, if I want to find this side here, I know that this side corresponds to this side. So I can take my original side length, which was 4, and I can multiply it by the scale factor, which was 3, and I get that this side length here has to be 12. Because the scale factor was 3. 4 times 3 is 12. Now this one I have to be careful, because I know that it should be getting smaller. So my scale factor needs to be less than 1. And it doesn't matter what shape it is, right? Whether it's triangles, or in this case we have a quadrilateral. I do need to find two corresponding sides. So I'm pretty sure that these two sides go together. I'm going to do new length divided by original. So my new length is 13. My original length was 52. And don't go do 52 divided by 13 and say the scale factor is 4, right? That wouldn't make any sense, because if the scale factor is 4, my shape should get bigger, right? But this is getting smaller, so I need to be careful. When I simplify this, I get 1/4. Or if you plug it in your calculator, 1/4 is 0.25. So my scale factor, I can say, is 1/4 or 0.25. So if I know that my original length here is 48, I can do 48 times my scale factor of 0.25, and 48 times 0.25, or 1/4 of 48, is 12. So I know that this side length here is 12 millimeters. Okay, we can also do scale factor from ordered pairs, as long as the center of dilation is the origin, which is the point 0, 0. So what I did was I went ahead and for this smaller triangle, I'm calling that my pre-image or my original, I went ahead and wrote down the ordered pairs from the original. And then if I go and I find the ordered pairs, right, of this one, right, and I call this my new shape or my image, I can still do the exact same thing I did with the side lengths. I can do that with the ordered pairs. I can take the new and divide it by the original. So, for example, if I just look at the x coordinates, my new x coordinate is 6, my original x coordinate was 2, and 6 divided by 2 is 3. My scale factor is 3. I can test it on some other places, so maybe I take these two, right? My new is 3, the original was 1, that's a scale factor of 3. Let me try a different ordered pair. If I try these two, right, those go together, same spot. If I take my new, which is 18, divide it by the original, which is 6, I get 3. Doesn't matter which ones I pick, as long as I do a new point divided by its corresponding original point, I am going to get a scale factor of 3. A couple more quick examples of that. The original, and then the new. And how do I know this is the new point? That's right, I know it's the new point because of the prime. So if I want to find the scale factor, I can just do the new divided by original, which is 4. So my scale factor, or my K, I like to call it SF for scale factor, but we can also call it K. My scale factor is 4. Is this an enlargement or a reduction? Well, scale factor was bigger than 1, so that is an enlargement. And I know that because K, or my scale factor, is greater than 1. I could also do it with the points 8 and 2, right? New divided by original, I still get 4. The scale factor is 4. You could also probably look at it and in your head do 2 times what gives you 8, and 3 times what gives you 12, right? 2 times 4 is 8. 3 times 4 is 12. So our scale factor is 4. This next one, I notice my numbers go from big to small, so it's going to be getting smaller, so I should be getting a reduction. If I take my new point of 4 and divide it by the original of 12, I get 0.33, or 1/3. So my scale factor, I like to use decimals. You can use fraction, either one is fine, it's the same thing. Scale factor is 0.33. Because this is less than 1, that will be a reduction. And again, I knew it was a reduction because my scale factor was less than 1. One more example. We're going from S to S prime, right? Prime is always the new. What's the scale factor on this one? That's right, the scale factor is 5. You probably just looked at it and went 10 times 5 is 50, right? Or you might have done what I taught and did the new divided by original, right? And if we take these 2 points, new one is 50, the original point was 10, and 50 divided by 10 is 5. If our scale factor is 5, is that an enlargement or a reduction? Well, because it is bigger than 1, that would be an enlargement. And like I said, we know that because our scale factor is greater than 1. All right, last little example. The red rectangle is dilated by a factor of 2 to make the blue rectangle. So this is an enlargement. When we did this enlargement, or this particular dilation, did we change the side lengths? Well, yeah, clearly I can see that this side went from 2 units to 4 units, right? It doubled. So yes, we definitely changed the side lengths. But did the dilation change the angle measures? Well, I have rectangles, and in a rectangle, I know that all 4 angles are going to be right angles, so they're all 90 degrees. when we dilated this, what are the angles of this rectangle? Well, it's still a rectangle, so your angles are still 90 degrees, 90 degrees, 90 degrees, 90 degrees. So did we change the angle measures? No. So we changed the size, right? How long it was, but we did not change the shape. So, are these two rectangles congruent? No, we know that congruent means to have the same size and the same shape, and these do not have the same size. So if they're not congruent, what are they? They are similar. So when we perform dilations or use a scale factor, which is doing a dilation, that's other than 1, right? Scale factor has to be greater than 1 or smaller than 1. When we do that, the two new figures are described as similar figures. More specifically, and the definition we'll keep coming back to over and over again, is that similar means to have the same shape, right? It looks the same shape, but not the same size. One will be larger than the other. So again, similar. Talk about this all the time. Same shape, but different size. And with that, we will see you later.